discussion. So today we will discuss a case study on challenges that we are facing in miniaturization of the electronic components. Okay. So electronic components are used everywhere in day-to-day life. In olden days, those components were very big, and because of that we face lot of problems. So we have reduced the size of the component with the help of many miniaturization techniques, and nowadays very small components are being evolved using the latest technology. So let us discuss what are the challenges faced, what are the advantages, disadvantages of miniaturization of the electronic components. So I will give you few time for discussing among yourselves, and after that we will share the points with each other. Okay, you can start your discussion. I hope you are sharing the points with each other. So can anyone else start?
Ma'am, based on today's topic, today we are going to say about miniaturization of electronic devices. So in that, we have to miniaturization of current electronic devices. So let us see an example. So vacuum tubes, in the later it was used in computers. So it has been developed, then it came IC and microprocessor like that. So we are miniaturizing the electronic device for our efficiency and compatibility. So we can carry it around, and it will be more useful than very effective in the society. So it is a very huge advantage, so that we can use it in many fields. So main disadvantage is so the reliability and the durability will be decreased. So if the product sizes decrease its original size to the minimized size, so the durability of the component will be decreased. Like the current will be leakaging. So like.
Today I am going to discuss about the challenges we face in the manufacturing miniaturization of electronic devices. Producing the components nanoscale requires precise techniques. Even a minor significant imperfection can lead to performance, reducing the performance or a complete device failure. Miniaturization of electronic devices involves reducing the size of the component, and it will lead to performance level and functionality levels. Fitting more transistors in the integrated circuit is also very difficult in today's technological.
Let us say about a power consumption. It's nothing but the power consumption reducing the device used to the power lessing. So the batteries are operated in the device, so we can reduce. By achieving this, we can control the speed and operating that. The power rating to the device, that's nothing but we can use to the device maximum power to supply. So we can in reducing the power, we can use to the device in many features.
So here I'd like to share about the challenge of materials limitation. The physical properties of materials is used in electronic components that can limits the further miniaturization and finding or developing the electronic materials that can function effectively at the nanoscale at dimensions is challenging.
Let's see about quantum effect in today's topic. So quantum effect, if we miniaturize in the electronic device, in the quantum effect, we cannot predict what will happen. So some leakage will occur. The heat will be emitted from the source battery. It cannot be the current source cannot be slowly passed. So many problems will occur. So the quantum effects are very unpredictable while miniaturizing the electronic devices. So let's see, there are many types of quantum energy are produced. So in that quantum tunneling, so in that it is leaking. So while the current is flowing, so it is making a tunnel. So like a tunnel, so it is leaking through the holes. So that is called quantum tunneling, and the energy quantumization. So we have the energy is quantumized. The quantum energies are used in laser technology and transistors. They are using the quantumized energies. And we can see also about the reliability and the durability. We have to rely on it, but the efficiency will be not much better compared to the oldest version. So if we reduce its size more and more, we cannot fit maximum number of transistors in it. So if we needed 100 transistors to fit in it, but we can only fit if we reduce its size, we have to make a new type of transistor. So that we have to fit it. So the reliability will be changed and the efficiency. So if um, transistors are doing a lot of work. So if we cut off the efficiency, if we cut off it of 50 transistors, have to do this work in the same time. So the efficiency will be cut off. So the reliability and the durability will be gradually decreased. So it is a main disadvantage in it. And the most main disadvantage is cost. So we have to we need to invest more and more. So we have to invest in it, so we can produce more things in the miniaturization of electronic devices. So the cost is very high. We need to improve the technology so we can control the cost.
Let's see about the challenges in electronic device. It's the heat management, components of integration and complexity, signals of interface, applications and uses. It is used for mobile devices and IoT sensors and medical device, and it's used for military and aerospace. It used for navigation system and communication device and surveillance drones. And also it is used for embedded systems. It is used for robotics and robotics in various technology uses.
As Kavya told, in miniaturization of electronic devices, all the electronic devices are used in our day-to-day lives. Best example is our mobile phone, right? So in the olden days, the mobile phone was very large in size when wireless technology was introduced, and later on several evolutions of mobile phone has been there from 1G to 5G. Now 6G mobile phones are being developed. So in the olden days when 1G and 2G was there, the size of the mobile phone was very large. Okay, and it was used only with a small number of features. But later on, when 3G, 4G and 5G got evolved, your mobile phone size also got reduced and more number of features has been added because of the latest technologies. One main disadvantage in mobile phone while reducing the size is the complexity of the device has been increased because all the components used are miniaturized. When a mobile phone is having any repair, so it is very difficult to analyze where the problem is, and so repairing the device is a bit complex task, right? So also power consumption also is very high. Battery will get drained fast because of the miniaturized devices. So even though miniaturized devices are giving us a lot of advantages, there are several limitations in that, right? Similarly, in military, everywhere we are using electronic devices with latest technologies, and all the devices are small in size, which are portable, so we can carry it everywhere. So miniaturization is very essential for the day-to-day life. Okay, good. Everyone shared your points very nicely. So we can conclude this discussion. So just I may give a gist about what we have discussed today. Miniaturization is very essential for the day-to-day life. So for miniaturization, first we saw about the manufacturing, what are the challenges faced in manufacturing. Then we saw about the thermal effect. So thermal is nothing but heating effect of the components. So we saw about that. Then we saw about the applications of miniaturization, and we saw quantum effect, what is the reliability, what we saw about the cost of the device, so how to reduce the cost of the device. So all these things we saw today. So thank you everyone for sharing your points. Thank you.